Good afternoon, class. We are looking at the exam 3 review, which covers 3.5, the chain rule, implicit differentiation and related rates, 3.7, derivatives of the logs, differentials, maximum and minimum values, how derivatives affect the shape of a graph. What I want to remind you is when you take the exam, you're supposed to read the following pledge. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam or any other exam for that matter. Unauthorized actions include but are not limited to the use of notes, text, graphing calculators, search engines, PowerPoints, or any other resources not explicitly allowed. I just want to make sure you realize that it is as though you're taking the exam on campus. So first, reminding you of the differentiation formulas from the basic definition to definition of E, trigonometric functions, product rule, quotient rule, exponential functions, logs, chain rule, and delta y versus dy. When you have a curve, the rise along the curve is called delta y, the rise along the tangent line is called dy. dy is precisely f prime of x times dx, and delta y can be approximated by that. Also, at a specific point, for example, P, we want to come up with the equation of a tangent line. The name is also linearization. That refers to the same thing. I just wanted to remind you of that. Now, when it comes to logs, of course, the base must be positive, can't be 1. And pay attention to this arrow. If you can follow the arrow and come up with the exponential format, log x base b equals y, means it's equivalent to the exponential format b to the power of y equals x, it makes it easy to follow and understand the properties here. When we write log, the base is 10. We shouldn't write the base 10. This is a common log, and we can see this transformation. When we write ln, the base is e. We shouldn't write base e, and those are the properties. Because of numbers 3 and 4, which refer to the fact that logarithmic and exponential functions are inverse functions, therefore the graph of y equals e to the power of x and y equals ln x must be symmetric with respect to the line y equals x. Here's the change of base formula. And this 3 refer to the fact this is the x-intercept at 1, 0. And when it's in between here, between 0 and 1, it's negative natural log. If it's beyond that, it's positive. Those are differentiation of logs with various bases. Let's get started. The first one is using the implicit differentiation to find dy dx, where 2x plus y to the power of 4 is equals x minus 2y. So we use the extended power rule. So 4 times the parentheses cubed times the derivative of the inside now by the extended power rule or the chain rule, whatever you want to call that. The derivative of the inside is 2 plus y prime or dy dx. That's the left side. The right side, x gives you 1 minus 2, y gives you y prime or dy dx. This is the only calculus step. Now to solve for y prime, we multiply this by 2, we get 8, and then we put the y prime in between. And on the left side, we get 8 times 2x plus y cubed plus 4 times 2x plus y cubed times y prime. And the right side doesn't change. Remember, we are solving for y prime. Therefore, we're going to move things around. This one moves this way, becomes positive because it involves y prime becomes plus 2y prime. And this one that doesn't have anything to do with y prime moves to the right, becomes negative. So we get 4 times 2x plus y cubed times y prime plus 2y prime equals 1 minus 8 times 2x plus y quantity cubed. Again, we're solving for y prime. So if we take this out, we are left with 4 times 2x plus y quantity cubed and 2 on the left side. The right side doesn't change. Now you divide by the brackets, and you call it dy dx of y prime is the right-hand side, 1 minus 8 times 2x plus y quantity cubed, over the brackets, which is 4 times 2x plus y quantity cubed plus 2. Notice we could take a common factor of 2 out from the denominator. However, since the numerator doesn't have a common factor of 2, you don't have to. We continue with implicit differentiation, sine y plus 2x cubed y squared equals 6. And to differentiate that, sine gives you cosine. So in essence, the derivative of sine is cosine. Cosine of what? The same argument y. For example, sine of gx is cosine of g of x times g prime of x. So this is cosine y dy dx. What about this one? We notice is the product of 2x cubed and y squared. We throw in a raised dot and we say this is f times g. We use the product rule. We get f prime, which is 6x squared, times g, which is y squared, plus g prime, which is 2y, y prime, or dy dx, times f, which is 2x cubed, and the right side is a number, becomes 0. So this is f prime g, and this is g prime f. And again, I put an asterisk. We are done with calculus. We are going to solve for dy dx. Before we do that, notice this is 4x cubed y dy dx. And so we keep these two, and we move this one. When we move this one, this becomes negative on the right side. Because we are solving for dy dx, we factor out the dy dx from these two, we get cosine y plus 4x cubed y. Now the right side, all we have to do divided by the parentheses and becomes dy dx equals the right side, negative 6x squared y squared, over the parentheses cosine y plus 4x cubed y. Find an equation of a tangent line to x squared plus 2xy minus y squared plus fy x equals 2 at this point, 1, 2. Generally speaking, to find the equation of a tangent line, you need a pair and you need this slope. We have the pair. To find this slope, we are going to differentiate, and we are going to differentiate explicitly. X squared gives you 2x, and 2xy is the product of 2x and y. Again, we write it as fg. Use the product rule on that. 2x gives you 2 times y. Y gives you y prime or dy dx times 2x minus y squared, the extended power rule, minus 2y y prime x gives you 1. Any number such as 2 gives you 0. We can plug in. However, let's solve for y prime. To do so, this goes to the right, becomes minus 2x. This becomes minus 2y. This becomes minus y, and we have this 2. We are going to write this as 2xy prime, and we keep this unchanged. Everything else moves to the right, becomes negative. On the left side, we're going to factor the y prime out. When we do so, we get 2x minus 2y. We are not touching the right side. But I want to add again, I can get actually 2y prime out. It doesn't help. Here's the reason. You're going to divide both sides by the parentheses 2x minus 2y, and notice the numerator doesn't have a factor of 2. If it did, you must take the 2 out because the denominator has a factor of 2 as well. Now, if you plug in, you get 7/2. I'm going to quickly show you when I plug in, I get minus 2 times 1, minus 2 times 2, minus 1, and the numerator is minus 7. The bottom is 2 times 1, minus 2 times 2, which means 2 minus 4, which means negative 2. And I hope you realize negative over negative is positive. And we use y minus y1 equals m times x minus x sub 1, which means y minus 2 is equals 7/2 x minus 1. This is 7/2 x minus 7/2. This moves, becomes positive 2 or positive 4/2. The final answer is y equals 7/2 x minus 3/2. Notice we can plug in 1 and 2. It works, which means this process is right. Meaning if the slope is 7/2, we haven't made a mistake. It doesn't say anything about this process. We're going to continue, everybody. Find dy dt for the equation x e to the power of y plus 4x equals y cubed, where dx dt is 2, x equals negative 1, y equals 0. The very first thing you need to notice, dy dt means t is the independent variable. Therefore, the derivative of x is no longer a 1, but rather dx dt. So we are going to differentiate this. We're going to put a raised dot in between, and we're going to use the product rule. I'm going to use the product rule on that. So the derivative of x, as I mentioned, it's no longer 1, it's rather dx dt. So dx dt times g, which is e to the power of y, plus now g prime f. What is the derivative of e to the power of y? Remember, any exponential is itself. And then because y is like g of x or a function, in this case, more specifically, g of t, because t is the independent variable. So it's e to the power of y. Instead of dy dx, we're going to put dy dt. So e to the power of y dy dt times x. So f prime g plus g prime f. 4x gives us 4 dx dt. Y cubed, we follow that. N y to the power of n minus 1 y prime, or dy dx. Instead of dy dx, we're going to use dy dt. So this becomes 3 y squared dy dt. Now, I've shown you in the lecture you can solve, and it's really a good practice to solve for dy dt. But at this point, you don't have to. Just plug in, which means replace whatever you have here. Dx dt becomes 2, x becomes negative 1, y becomes 0. Plug in. When we plug in, of course, e to the power of 0 is 1. And the right side, 3 times 0 squared dy dt is 0. So what you have is 2 minus dy dt plus 8, where 2 and 8 add up to 10. So 10 minus dy dt is 0. That means dy dt is positive 10. Differentiate 2x times ln of 3x squared. When log is involved, the best course of action is to simplify, to decompose it first. In this case, actually, you don't need to. It makes it more difficult. So we are going to put a raised dot in between and say this is f times g, again, using the product rule, f prime g plus g prime f. So y prime, the derivative of 2x is 2 times g, which is ln of 3x squared, plus the derivative of ln of 3x squared, or g. You flip this over. We are going to go with the natural log, and of course, the natural log of g of x. We flip it over, 1 over 3x squared. Times g prime, the derivative of 3x squared is simply 6x. And then remember, this is g prime. Now you need f times 2x. So you have f prime g plus g prime f, and this entire thing is 12x squared over 3x squared, which is simply 4. So the final answer is y prime equals 2 ln of 3x squared plus 4. Now, in this case, if you don't decompose, you have to flip this over and then use the quotient rule. It's really not recommended because it's much easier to decompose the log first using number 6. I'm going to do it in 2 steps. It can be done in 1. So the first one is the quotient rule, which means you say ln of the top 5x minus ln of the bottom ln of x squared plus 5. Then you notice that this one, ln of 5x, we can use the product rule and write it ln of 5 plus ln of x. ln of 5, because it's a number, gives you 0. Ln x, of course, is 1 over x. So y prime is 0 plus 1 over x. Minus, now we are going to go with ln of g of x. So flip this over, minus 1 over x squared plus 5. The derivative of that would be 2x, the derivative of x squared plus 5. And we're done with calculus. So the next step is to use algebra and find LCD, x times x squared plus 5. This is 1 times x squared plus 5. And this one is minus 2x times x. And we get x squared plus 5 minus 2x squared, where we can combine these two, and the final answer becomes y prime is minus x squared plus 5 over x times x squared plus 5. So again, pretty straightforward, everybody. G of x is log of 9 minus x cubed to the power of 4, and decomposition of log is the first step. If you look at this number 7, the power rule, we can put the 4 in front. And then we follow the rule. So if I want to differentiate this, I have 4, of course. I flip this over. 1/9 minus x cubed. Then I need the derivative of that, which is negative 3x squared. Then when I look at the base is missing. LOG means the base is 10. So when there is no base and it's LOG, the base is 10. So I need 1/ln b, 1/ln 10. So the final answer, we put these two together in the numerator as negative 12x squared, these two together, and we get 9 minus x cubed ln 10. The reason we write it in this fashion, because if you put this expression after 10, it may be confusing as part of natural log, which is not. So it's 9 minus x cubed times ln 10 as the final answer. Y is f of x equals x squared over x minus 8. We want to find dy. The moment you hear dy, ignore it and go with the derivative. So find f prime of x over dy dx, and that means we have to use the quotient rule. F prime g minus g prime f over g squared. So you write down f prime of x or dy dx is the derivative of the top, which is 2x, times the bottom, which is x minus 8, minus g prime, which is 1, minus 1, times f, which is x squared, over the denominator, x minus 8 squared. This is the extent of the calculus. You simplify the numerator as follows. 2x squared minus 16x minus x squared is to combine into x squared. So we get x squared minus 16 over x minus 8 quantity squared. Is this dy? No. What is dy? The same thing times dx. Find dy and delta y when x is 4 and dx or delta x equals 0.2. Simply put, plug in for dy. Replace the x with 4 and delta x or dx with 0.2. This is the calculation. You don't even need the calculator because 4 squared is 16, minus 16 times 4 is 64. So 16 minus 64, the bottom is negative 4 squared, you get 16. So we have negative 48 divided by 16 is negative 3. Multiplied by positive 0.2, you get negative 0.6. That's why a lot of times dy is an approximation of delta y, because normally it's easier to calculate. If I want to calculate delta y, or f of x plus delta x minus f of x, I need to calculate f of 4.2 minus f of 4. Which means into this function, you put 4.2 and then 4. Now, of course, this is easy to calculate. This one is also easy. You can do it by hand, but most likely you do it by calculator. And that's why this is easier to do it without the calculator. So you plug in, you get numerator at 17.64 over negative 3.8 minus numerator is 16 over negative 4, and the result is negative 0.6421. Again, the two values, as expected, are pretty close. Section 3.8 differentials. Example 9, use differentials to approximate cube root of 63.5. So we need two things to do so. Number one, we need a function. Anybody knows which function we may use here? We look at the operation. The operation is taking the cube root, so the cube root of x. The next thing we need, we have to choose a number which is close to the given number 63.5, and we know the cube root of that number. Anyone can give us that number? What is the closest number to 63.5? We know the cube root of. Cube root of 64, because we should know it's 4. So now dx or delta x is the difference between the two. 63.5 minus 64 is negative 0.5. And it is important to understand why it's negative. We know cube root of 64 to be 4. We don't know the cube root of 63.5. And this negative indicates it will be smaller than that. On the other hand, I want to make sure we understand that if by any chance the question was asking for cube root of 65, then your dx would be positive 1, because 65 minus 64 would be positive 1. All right, so we are going to use the approximation. F of x plus delta x is f of x plus dy. We have f of x, we don't have dy. Therefore, we have to first differentiate it in order to get to the dy. We know it's the product of f prime of x and dx. So we rewrite this as x to the power of 1/3. It's easy to differentiate. It's 1/3 x to the power of 1/3 minus 1 over negative 2/3. And we've done that many times before. Negative 2/3 goes down, becomes x to the power of positive 2/3. Or 1 over 3 cube root of x quantity squared. dy is exactly the same thing times dx. So when you multiply this one by dx, you can put it in the numerator. 1 times dx is dx. So now we are going to write that this piece comes from this cube root of x, and this comes from here. And we are ready to plug in. So cube root of 63.5, which is f of 63.5, is f of 64 plus negative 0.5. It's important to put a plus here, negative here, meaning this is your x, this is your dx. This is your x, this is your dx, and plug in. So when we plug in, obviously, this is 4. So that's not a big deal. 4 squared is 16 times 3 is 48. So we write this 4, and we write this as negative 0.5 or negative 1/2. Why am I changing this to a fraction? Because I don't want to use a calculator. I want to show you, remember, 1/2 over 48, that means 1 over 2 times 48, that means 1 over 96. 4 minus 1 over 96 is 3, and 95 over 96. I want you to first pay attention to this part. Does not require any calculator, everybody. Then I'm using a calculator for a reason. And the reason is, if we put this one originally into a calculator, we get this number, which is identical within the first 4 decimals. In fact, if you want to stop here, you have to round it to up to 6, because the next one is 5. The same thing here. So up to 4 decimals, they are identical. Again, you should be able to handle the fraction, because there is no need for a calculator, and this part is just a matter of comparison. And the reason this is fairly close to that, because delta x or dx is very small compared to the choice of x, which is 64. We are done with that. However, I hope you remember linearization refers to finding L of x, basically finding the tangent line. Linearization refers to finding the tangent line. So what we want to look at is that the tangent line gives you the same result. So if you want to find the tangent line or L of x, what is your function? Your function f of x is cube root of x. At what point? At x equals 64. We need a pair. We need the slope. What is the pair? You just plug in. Obviously, if you plug in, you already have the answer here, 64, 4. What about the slope? In order to find the slope, you plug in to f prime of x, to this function. And if you plug it into this function, remember, cube root of 64 is 4, square root is 16 times 3 is 48. So 1 over 48 is the slope. We are going to use this formula, y minus y1. That means y minus 4 equals m. That means 1 over 48. X minus x of 1 means x minus 64. If you distribute and simplify, you get y or L of x is 1 over 48x plus 8/3. That's the tangent line, everybody. Now, if you replace the x with 63.5, it gives you exactly this answer. And the way you do it is very simple. 63.5 divided by 48. You multiply the top and the bottom by 2. The bottom becomes 96. The numerator becomes 127. Combine two fractions, you get exactly this number. And I leave it for you to show that, everybody.